Alright, we're going to continue with our systems of equations. In this lesson we're going to look at solving a system by substitution. And we've actually done a little bit of this already in previous units when we're solving word problems and things like that. And basically substitution is just like it sounds, we just substitute one equation into the other. So you can see in this case, if we have one equation being equal to x equals 2y minus 3, we can actually just plug that entire thing in. So in this case we'd have 3 times 2y minus 3 minus 7y equals negative 14. And if we FOIL that out, and we could rearrange and solve it, so we get minus 1y minus 9 equals negative 14. And if we add 9 to both sides, we'd have negative y would equal negative 5. Divide by negative 1, we get y equals 5. And then what we'd have to do is substitute that back in to solve for x. So we'd have 2 times 5 minus 3, which would be 7. So in this case, our solution would be x is 7, y is 5, and we're done. So it's just an alternate way of graphing, and in some cases it works a little bit better than graphing, other cases not so much. So the steps you want to do to solve by substitution is usually, especially when you get into quadratics, we want to isolate one of the equations for y equals. So get one of the equations to be y equals, then we're going to substitute that whole thing in for y in the other equation, solve the equation for x, and once you have the x, go back to your equation to solve for y, and that's it. So let's go through a few different examples. So you can see in this case we have our two equations, and one of them, they're already both y equals, so this would be an easy one to graph, but let's try it by substitution. So let's substitute the x minus 2 in for y for the first equation. So that would give us this. Let's bring the x over, so let's minus the x on both sides. So that'll give you minus 2 equals x plus 5, and let's bring the 5 over to the other side. So we get x equals negative 7. And so all we need to do is figure out our y, so we could put that negative 7 in either of them. Let's use the second equation, it looks a little easier. So negative 7 minus 2 would give you negative 9. So negative 7, negative 9 is our correct solution for this system. So that coordinate will work for both equations. Okay, if one equation is not y equals, you can see this one already has y equals, so let's just plug that one in. We don't have to do anything with the second equation. So we'd have 3x minus 2 times 2x plus 4 equals negative 4. Just be careful when you FOIL that out, that negative is going to change both, so minus 4x minus 8. And let's simplify that, so we'd have minus x minus 8 equals negative 4. Let's bring the 8 to the other side, so that'll give you plus 4. And divide by negative 1, so we get x equals negative 4. Plug that back into our y equation. So 2 times negative 4 plus 4. So that gives us negative 8 plus 4, which is negative 4. So in this case, our coordinate is negative 4, negative 4. So it works well. It's just a little bit more math, but some people like it better than graphing because it's a little bit more accurate, and you don't have to worry about graphing it and things like that. So let's do another one. Here we have no y equals for either. So first of all, let's rearrange this first equation for y. So let's bring the y over and the 10 over the other way. So that gives us 5x minus 10y. Then let's plug that in for y into our second equation. So we'd have 0 equals x squared plus x minus 2 times 5x minus 10. And simplify that. So we have minus 10x plus 20. And let's simplify that as a quadratic. So we'd have minus 9x plus 20. And remember, with quadratics, we want them equal to 0 so that we can factor. So in this case, minus 5 and minus 4 would be our factors. So our x is our positive 5 and positive 4. So the only thing we got to do differently now is we got to plug both of those into our y equals. So let's go 5 times 5 minus 4. And that'll give us 25 minus 4, which is 21. So that means our first coordinate is 5 and 21. And then let's do the same thing with 4. So you'd have 5 times 4 minus 10. So that's going to be 20 minus 10, which is 10. So that means our second coordinate then is 4 and 10. So in this case, we get two solutions, but remember when we do these in terms of graphing, if we have a quadratic and a linear, quite often we do get indeed two solutions. So it works the same with quadratics, doesn't make anything different. You just have to factor it out like we normally did with quadratics and then solve for both equations. So here's another one, another quadratic they're both quadratic, so we need to make one of them y equals. So let's just make this one switched around. So we'd have 6x squared plus 4x minus 4 equal to y. And then let's plug all of that in for y into the first equation. So let's rewrite it all out. So we'd have 3x squared minus x minus the whole thing. So minus 6x squared plus 4x minus 4 minus 2 equals 0. And that negative out front is going to change all of our signs. So minus 6x squared minus 4x plus 4. And let's just simplify all that. So we'd have minus 3x squared minus 5x and minus plus 2 would be our leftover part. And it's a little bit hard to factor with that negative, so let's flip things the other way around. So let's make it plus 3x squared plus 5x minus 2. Now we can try factoring it, so it should be 3x and 1x, and we should get 1 and 2. And we want it to be plus 5, so plus and minus should work. Does that work? We get negative 6x. Oop, wrong way around. So it should be 3x minus 1, and x plus 2 should be our correct factors. So if we FOIL that out, we get 3x squared, which is good. We get 6x minus 1x, which gives us the 5, and minus 2. So our solutions will be 1/3 and negative 2. So once again, plug those back into your y equals. So let's try each of those. So it'll be 6 times 1/3 squared plus 4 times 1/3 minus 4. So that gives you 1/9 times 6, so that's 6/9, so that's 2/3 plus 4/3 would be 6/3, which is 2. 2 minus 4 is negative 2. So 1/3 negative 2 should be our first coordinate. And do the same thing with negative 2. So 6 times negative 2 squared plus 4 times negative 2 minus 4. So that gives us 24 minus 12, which is 12. So for that one, our coordinate should be negative 2, 12. So those would be our two solutions for this system of two quadratic equations. So you can see it works. So you can see it works pretty well. You just have to substitute it in and then end up solving one quadratic or a linear. And here's a few practice questions. So if you want to get a little bit of practice before we try the worksheet, here's two where there are some that are y equals already. So you can see in this case probably the easiest would be just plug that 2x in for the other y. And you can see here we got another y equals equation, so we could plug one into the other, or if we wanted to, we could solve this first equation, just move the y over. So that'd be 2x minus 7, we could plug that in for the y there, and so on. So here's some practice ones, you can give them a try if you want, and then we'll be continuing with our next method tomorrow.